Hey guys, today we are going to be looking at performing operations. That means we're going to be looking at adding, subtracting, multiplying, and dividing. In scientific notation, we're trying to keep scientific notation easy. Easy. Okay, so let's go ahead and get started with our notes. Go ahead and title this Operations in Scientific Notation, and your essential question is how can I perform operations with scientific notation? I'm just going to go ahead and jump into examples and we're going to take a look at them. Okay, when we're looking at addition and subtraction, there's two things that we need to look at first. Okay, are the powers the same? Are powers the same? Aw. One second, let me get my slides going again. Sorry, my pen's too close to the edge. Okay, are the powers the same? And if they're the same, you can do the easy way, but if they're not, you go here and you do it by order of operations. Order of operations. Order of operations. Please excuse my dear Aunt Sally. So if they're not the same, you're going to do, please excuse my dear Aunt Sally, order of operations. If they are the same, you can do the easy way. So let's go ahead and take a look at example 1. Are the powers, we have this 10 squared and 10 to the negative 1 the same? The answer is no, so we have to go through order of operations. So parentheses first. Inside the parentheses, we're going to work on these exponents here. Okay, 10 squared is 10 times 10, which is 100. Okay, 10 to the negative 1 is 1 over 10. All right, let's rewrite. 8.2 times 100 plus 3.141 times 1 over 10. Okay, now we have to do our multiplication. So we're going to do our multiplication here and our multiplication here. Okay, 8.2 times 100 is 820 plus 3.14 times 1 over 10 goes to 3.1441 over 10. Okay, some scratch work that we're going to erase. 3.41. 3.41 divided by 10. How decimal is going to go here. Okay. How many tens are in 3? There are no tens in 3. Okay. How many tens are in 34? 3. 4 remaining. Carry down the 1. How many tens are in 41? 4. Okay. That's 40. Carry down the 1. Since we already have a decimal place right here's that decimal, we're going to add a 0 and we're going to drop it down. How many tens are in 10? 1. All right, so this actually says, our new line says 820 plus 0.341. 820 plus 0.341 is 820.341. Let me go through and erase that. 0.341. Now we just need to write this in scientific notation. In order to put this into scientific notation, we need to move our decimal place 1, 2 decimal places. So in scientific notation, this would say 8.20341 times 10. Is this a big or small number? It's a big number, squared. I moved it twice. Right here's where I moved it twice. Okay, I need to pause my video and erase my board so I can move on to example 2. So if you don't have this done, please pause your video now. All right, example 2. Are our powers the same? Yes, they're the same. So we can use the factoring out, the opposite of distribution, and pull them out because they are the same. Super important. They're the same. And we're only looking at them when they're the same, when they're addition and subtraction right now, okay? So adding and subtracting, these are your examples for adding and subtracting. Okay, so we're going to pull those out because they have the same factor, same multiplication of 10 to the negative 5. So 10 to the negative 5, if I pull this out here, all I have is 7.8 minus, pull this out here, 4.5. 7.8 minus 4.5 is much easier to do. 7.8 minus 4.5. Order matters, has to go in this order. 8 minus 5 is 3. Carry down the decimal. 7 minus 4 is also 3. So now we have 3.3 and 10 to the negative 5th. We don't write scientific notation like this, so we're going to rewrite this in the proper format. 3.3 times 10 to the negative 5th, and we're good. We're good to go. Okay, our factor right here is in the right, is in between 1 and 10, and we're good to go. Okay, let's go ahead and look at finding the product and quotient. Product and quotient. Product is multiplication. Quotient is division. So now let's add some examples about multiplication and division. Okay, with multiplication and division, life does get a little bit easier. We're not so much worried about we're not worried at all about our powers being the same. We're just setting up this problem. Okay, if we multiply any numbers, this number 3 says multiply and multiply. So we're going to associate things that make sense. For example, I'm going to associate this 6 and this 8 because it makes sense to do that. Okay, 6 times 8 is 48. So 48, I did the multiplication here, and I still have times 10 to the negative 5th. Okay, 48 is not proper format. I'm going to move my decimal over one place, so I'm adding another multiplication of 10. So 10 to the 1 is another multiplication I added in order to get 44.8. 10 to the negative 5th. Okay, now I'm going to combine. I have two powers with the same base that are being multiplied, so I'm going to add their exponents. I'm going to add their exponents right there. And so written in scientific notation, example 3 is 4.8 times 10 to the negative 4. All right, go ahead and pause your video because I got to erase this to give myself some more room. All right, example 4, we're going to use that commutative property. We're going to put these two numbers next to each other and these two numbers next to each other because it says multiply in between. Multiply here, and multiply here. We can do this. Okay, so 7 times 3 times 10 squared times 10 to the 5th. All right, now I'm going to associate these two with each other and those two with each other. 7 times 3 is 21 times 10 squared times 10 to the 5th is changing the exponent to 2 plus 5. 2 plus 5 is 7. So the exponent is 7, so 10 to the 7th. Sorry, let me rewrite that. It says 21 times 10 to the 7th. Okay, but this isn't in scientific notation. We're going to take our decimal and we're going to add in 1 decimal place. We're going to add in 1 decimal place right here. So we're adding in a multiplication of 10 to the first. So when we add in that multiplication of 10, our exponent gets slightly bigger and it says 2.1, and then 10 to the first and 10 to the 7th can be simplified. 1 plus 7 is 1 plus 7 is 8. 10 to the 8th exponent. 8th exponent. There we go. Now it's in scientific notation. Right there. Okay. Number 5. Let's look at number 5. When we're dividing, let me go ahead and set this division up so you can see what's going on. We have this 9.2. This 9.2 times 10 to the 12th over this 4.6. Okay, what we're going to do is we're going to chunk this so that we're dividing these two numbers, okay? And if they're dividing these two numbers here, okay? So essentially this 10 to the 12th is going to stay the same. 9.4 divided by 4.6, again 9.2 divided by 4.6 is 2. So this simplifies right down to 2. 10 to the 12th divided by 1 simplifies down to 10 to the 12th. And these two, they're still being multiplied. I didn't lose my multiplication. I just simplified the division, and you wrote it in scientific notation. Okay, so you're going to divide the factors, and you're going to be doing, I'll show you in the next problem, what to do with the exponents, okay? Number 5 is good to go in scientific notation because this 2 right here is in the right format. So 6, let's set 6 up for division. It says 1.5 times 10 to the negative 3, 10 to the negative 3 over 7.5 times 10 squared. Okay, so we're going to do the division between these two numbers and the division between these two numbers. So I'm chunking them. 1.5 divided by 7.5 is 0.2. 0.2 times 10 to the negative 3, 10 to the negative 3 divided by 10 to the 2. We're going to do negative 3 minus 2. This is our quotient of powers property, and this is negative 5. So times 10 to the negative 5. This is not in proper scientific notation yet. We need to take away a decimal place, not add in a decimal place. We need to take away a decimal place. So we're going to have 10 to the negative 1. We took away a decimal place, so 10 to the negative 1. Okay, times 10 to the negative 5. And we changed that 0.2 to a 2. So now it's in scientific notation. Let's go ahead and simplify the problem. 2 times, we have 10 to the negative 1 right here, and 10 to the negative 5 here being multiplied. So add them together, times 10 to the negative 6. All right. Go ahead and try these 6 on your own problems. Answer this essential question. And when you're ready to check your answers, go ahead and resume. All right, here's what we should have gotten for all of these problems here. Okay, number 1, you should have done the easy way because they have the same exponents. Number 2, you should have used order of operations. Please excuse my dear Aunt Sally. Okay, number 3, you should have done this the easy way, chunk them out, okay, and then just subtract the 2. okay, 4 and 5, you actually had to do